Okay, so we will see what is the usual, what is the formula for two usual shape, a rectangle load or a triangle load. Okay, so let's do try to organize I will do here we go, oops. First, rectangular load. Okay, so here we go. We have both formula that we found previously with integral notation. Okay, so let's write our rectangular load. That's the ax, and the load there. Rectangular load is all the little df going down, right, like this. Okay, and because it's a rectangular load, the w, it's constant, right? It's just a number, maybe 100 Newton per meter, maybe 25 pounds per feet, something like that. It's just a number that doesn't change. Into this df. Okay, so first, and the length, I need the length. Oh, should not do that. And the length there, I know it is L. Okay, so the first question, what is FR? So FR is equal to the integral on L of W of x dx. That's the general formula. But here, W, it's constant on L. So FR is equal to W. I can take it outside the integral sign because it's constant on L of dx. So finally, FR is equal to W, and dx, the integral of dx on L is just L. Okay, it's like if we add, so the integral on L of dx is like we add all the little dx together. We add all of them, and at the end, what we have is L, the distance L, the length L. Okay, so if you have a distributed load, the resultant force is W times L. That makes sense because it's also the area of the rectangle, right? You'll see everything will make sense. I just want to show you where the formula comes from. Okay. Now the X bar. Okay. Let's do the X bar. I will rewrite the formula anyway. Okay, so X bar, it's equal to, so what is X bar? X bar is, let's say we found FR to replace this load, and now we need to find the location from the point O there. Okay, so we say that X bar, the formula for X bar is, let me take a little bit more space, equal to the integral of W x times dx, or x w x dx on L, divided by the integral of W x dx. That's the general formula, and this one is FR. Okay, so W is constant, so we can take it outside, so it's W integral on L of x dx, and the integral of W of x dx is what we just did before, is FR, so it's W times L. Okay, so let's keep going with that. So X bar, it's equal to, so we have W divided by W, that is 1. And the integral of, okay, let's do it in the next steps. So W, and the integral of x dx. So if we take the integration of x, we need to use x squared divided by 2. Okay, on L. And below is W times L. Okay, let's now remove W and W. W divided by W, it's 1. Okay, so X bar is equal to X squared, and I replace by L, so it's L squared. The divided by 2, I can put it below the fraction sign, times L. So X bar is equal to L squared divided by L. We just have L left, so it's 1/2 times L. Let's square that. Oops. Okay, So it means that X bar here, it's L divided by 2. That makes completely sense, okay? FR is in the middle of your load, okay, because it's a rectangular load. But now you can, you understand the process to prove it. So now that we have proved those two formula, you can use them. Okay, if you have a rectangular load, you can apply right away FR. Let me square that a bit bigger. It's equal to W times L, and the location of FR is in the middle of the load, so 1/2 of the length L. So that's for the rectangular load. Now let's do the triangular load. That's a bit more tricky. Triangular. You know what? Let's come back from the beginning. I need space for this one. Oops. Yeah, we probably need all of the space. So here we go. Okay, right. Now triangular load. Sorry, load. Here we go. Okay, so let's draw a rectangular load. So I will make it in these directions. Okay, so the load increase with the distance, and that's very common. It's very common one. So this point there is W. Let's me. So the maximum of W, I will call that W max. Okay, that's the maximum load. This one is the base of the triangle. Okay, and this point is the top of the triangles. Let me increase that a little bit for you. Oops, here we go. Okay, and the formula, and what we know also is that this distance, we call that L. Okay, and this one is a base, and we call it B. Okay, now the function W, and let me write it in small, W of X. What is W of X? Okay, that's a function of a right that increase slowly with the slope. The slope is y divided by x. So the slope is b divided by L. Okay. So for example, at 0, W is when x equals 0, W equals 0. And when x is equal to L, b times L divided by L, W is equal to b. So W of x is equal to the base divided by the length of the triangles, like this. I can say the h of the triangles. Let's put the 8 of the triangles. We call that more the h. The 8. Okay, so this one it's equal to the 8 of the triangle. Like we flip our triangles. B divided by h. Okay, time x. Okay, that's the function. Okay, so we have everything we need. So first, FR, formula for FR. Remember the formula for FR? We can look at it there. The integral of W of x dx. So the integral of W of x dx on L. So FR is equal to the integral of L. W of x is B divided by H x dx. So FR is equal to, so B divided by H, it's a constant. Integral of x dx on L. So FR is equal to B divided by H x squared divided by 2 on L. Okay. The integral of x is x squared divided by 2. So FR is equal to B, not L. Okay, sorry, I call that H. So the L here is H. Oops. Here we go. On H, so I replace by, so B divided by H squared divided by 2. Okay, for triangles, we call that more the 8 than the length, the 8 and the base. But that's the same thing, okay, that this distance there, H. So FR, finally, FR is equal to B times H squared divided by H is H divided by 2. And that's the formula for the resultant force for the triangle. Okay, so that's the first steps. That makes sense. That's also the area of triangles, right? B times H divided by 2, usual shape. So that's FR. Now, the question is, where is FR? Do it there. We can feel that it's more to the right than to the left, because there is more load to the right than to the left per unit, because the load per unit increases slowly. So what we will use the exact same property formula than we did in the previous sections. We will say that the sum of the moment. Oh, no, we don't have to do that. We can just do this one. We can just use this X bar formula again. Okay, so we use this formula. So X bar increase. What is the formula for X bar? We proved it already. Let's do this. It's equal to the integral of X WX dx on H, because X vary from 0 to H in your case, divided by W of X dx on H. Same. Okay, so X bar is equal to, and this one below, the integral of WX dx, that's what we found is the FR. So it's BH divided by 2. Okay, and the integral of an H of X W is equal to B divided by H X dx. Okay, let's clean that a little bit. So X bar is equal to BH divided by 2. We can write it, that is 2BH in front, time B divided by H there. We can take it outside because it's a constant. And we have the integral on H of X times X is I square dx. I promise we are almost there. Okay, let's keep going with this one. So X bar is equal to 2 times B divided by B H times H. So it's make 2 times H square time X square. It's X cubed divided by 3, and it's on H. Okay, X squared dx, that's X cubed divided by 3. So X bar it's equal to 2, and I have 3 that can take in front. So no, okay, I will do in the next steps. Time X cubed, I replace X by H cubed divided by 3. We are almost there. So X bar is equal to 2 divided by 3, 2/3, H cubed divided by H square, H. We are there. So the location of FR, this one, this distance there. Yeah, can you see something? This distance there is H divided by 3. That's what we call X bar. So let me put this everything in context. So we have everything on once at the same time. So the resultant force of a triangle load first is BH divided by 2, and its location is 2/3 from the top. So that's from the top. Okay. If we want to describe it from the base, so this distance there, that will be H minus, oops, I forgot the 2 there, sorry. That will be, this one will be only H divided by 3. Okay, So x bar is equal to 2/3 times h from the top of the triangles, or x bar is equal to 1/3 times h from the base of the triangles, from this base. Okay, so the force of friction is 2/3 from the top, 1/3 from the base, and it's a very common mistake to mix the 1/3 and 2/3. Okay, and think that what we have there, let's use this highlighter. What does I mean is mean that we have the same area with this load than with this load. Okay, we have cut the distributed load into exact same area. Okay, so that's where is the location of the force, the resultant force. Okay, so let me know if you have any questions, but now you can use those, or let me make them golden because they are so useful, those formula. This one, this one, this one, and this one, you can use them. Okay, I don't ask you to reprove them. Never. Okay, just use them if you have a rectangular or triangular load. We use this formula integrals when we have a distributed loads that is described by a function. Okay, and you have the W of x. Okay, so see you for the problem in the next video. Bye bye.